After doing the IUPAC nomenclature of alcohols and phenols, we will start with the preparation methods of alcohol. Now, the part that we are going to go today, the reactions that you will be seeing in today's video, these reactions are not given in the textbook of 12th standard. You may find these reactions, some of them in 11th standard textbook and some of them are given in other chapters. But I have collected all the reactions together and you will be seeing the reactions in the video. So pay attention and see it properly. Now the preparation methods of alcohols in this. The first preparation method is from alkyl halides. The process is called as hydrolysis. Now what do we use? We are going to use aqueous base, that is either NaOH or KOH, or you can also try the reaction by using moist silver oxide. So let's see first reaction. This is ethyl bromide when treated with base NaOH or KOH. This is aqueous base, that is it contains more amount of water. NaOH or KOH, when heated, there is formation of ethyl alcohol or ethanol along with NaBr. This is a substitution reaction where Br is replaced by OH. So you get an alcohol very easily in the reaction. The reaction can be tried with KOH also and you will get the byproduct as KBr. In the other reaction where we are going to use moist silver oxide, which has formula Ag2O, as it is moist, it contains water in it. Water and silver oxide together produce silver hydroxide. So ethyl bromide when treated with moist silver oxide. This is the formula of silver oxide. And what do we get due to moist silver oxide? You get silver hydroxide during the reaction. And in the product, again Br gets replaced by hydroxyl group, OH group, and you get formation of ethanol along with AgBr. See, this is important. Here you cannot write Ag2O. This should come on the arrow and this produces silver hydroxide to form an alcohol. Second preparation method is by hydration of alkenes. What are we going to use? In the reaction, we are going to use cold and concentrated H2SO4 in first step. And in second step, the intermediate which is formed in the first step will be treated with water. So two steps madhe the reaction takes place. Let's see the reaction. We have ethene. So see, you might have seen in previous reaction as well as here, the reactants and products which are simple. I have not written their names because you are very much familiar with the names. But the products or intermediates which are new, in those I have written the names. This is ethene, alkene. This is treated with cold and concentrated H2SO4. This is the first step. This H2SO4, for your understanding, is written as HOSO3H. Now, when the reaction takes place, it's an addition reaction where the double bond will break, hydrogen will get attached to one carbon and OSO3H group will get attached to other carbon. So this is the case. CH2 becomes CH3 after attachment of one hydrogen and CH2 la OSO3H group attach hoto. Now you can notice here that OSO3H group. You can notice here that this OSO3H group is nothing but it is SO4H group. But Litana, it should be written as OSO3H. You cannot write like this in the reaction part because attachment of carbon is with oxygen. If you write SO4H, the attachment of carbon will come with sulfur, which is not correct. But to give the name to the compound, this gives us a hint that the compound can be called as ethyl hydrogen and sulfate. SO4 is sulfate. So it becomes easy as ethyl hydrogen sulfate is formed. Ethyl hydrogen and SO4 is sulfate group. Hydrogen sulfate. This is the intermediate. What is intermediate? During the reaction that is formed in between is called as an intermediate. This is an intermediate formed. This ethyl hydrogen sulfate is now treated with water or heated with water. Again, water चा breakdown कसा केला है? H and OH. So CH3, CH2. The bond breaking takes place here. At this point, the bond breaking takes place. CH3, CH2, OH gets attached to the alkyl group to form ethanol, and remaining O, SO3H combines with H to form H2SO4 again. So what is the speciality of the reaction? Whatever was the starting substance that we used, the reagent, that reagent you are getting back in the reaction at the end of the reaction. Same reaction now we will try with propene. Why is this tried? Why have I shown two reactions? Because ethene was an alkene which was symmetrical. Now propene is an alkene which is unsymmetrical, and you will find that in this case, as it is unsymmetrical alkene, you will be using the knowledge of Markovnikov's rule. So let's see. Propene, when treated with cold concentrated H2SO4, forms isopropyl hydrogen sulfate. Let's see the reaction. In the reaction, OSO3H, this is the negative part, and H plus becomes the positive part. So you will find that according to Markovnikov's rule, during addition of unsymmetrical reagent to unsymmetric alkene, the negative part gets attached. This is the negative part. But the negative part of the reagent gets attached to the carbon that contains less number of hydrogen atoms. So this is Markovnikov's rule. So you find that OSO3H group, which is negatively charged, will get attached to the carbon that has less number of hydrogens, only one hydrogen. So central carbon gets OSO3H group, while the other double bonded carbon gets hydrogen with it, and there is formation of isopropyl hydrogen sulfate. Isopropyl का word आला because OSO3H is present on the central carbon. Isopropyl. हा OSO3H end ला असता तर you would have called it as N-propyl hydrogen sulfate. This is isopropyl. Central carbon ला आला है. 3 carbons मधून. This isopropyl hydrogen sulfate is then treated with water. You get formation. What will happen? Again, OSO3H group will be replaced by OH. So on the central carbon, you get OH getting substituted, and there is formation of H2SO4. So as compound was iso, as an intermediate, the product also formed will be isopropyl alcohol. What should be the IUPAC name of the compound? It should be propane 2-ol. This is the IUPAC name of the compound. See, if I have written the common name, try to recollect the IUPAC name of the compound, because we have to give more importance to IUPAC name.